Hey guys, I will be doing my presentation on the aviation advancements made during World War II, specifically as it relates to the creation of the jet propulsion engine. Before we start, I just wanted to highlight the B-29 Superfortress bomber that you can see on the screen here. I will not be touching on this plane much, but this plane was huge in the Americans' onslaught of Germany and the rest of Europe during World War II. This would be their main bomber, and there are many shows and documentaries just related to this aircraft. Before jet propulsion, the Germans had air superiority over all of their enemies at the beginning of World War II. They had more advanced jets like the Messerschmitt 109 and the twin-engine Me-110. Me is just short for Messerschmitt, so from now on I will just be using Me. Both of these planes could go up to 350 miles per hour. However, the 109 only had one engine and was significantly lighter, giving it better maneuverability. The Germans would use a formation of both these planes, giving them a huge advantage in the early stages of the war. Both of the original models of these planes were retired in late 1939. However, they were both still used throughout the rest of the war in upgraded models. The Germans experienced their first struggle against the British Royal Air Force in 1940. And at the top right up here, we have the original model of the Me-109. The British Royal Air Force made a good match for the Germans in 1940. The first plane being the Hawker Hurricane, this plane could outmaneuver the German Me-110. Partnered with these aircraft were the Supermarine Spitfires that the Brits created. These planes could keep up with and even outspeed the German Me-109s. However, they did not have the same firepower capability that came along with the Me-109. The more advanced radar systems Britain has on the ground, along with the equally matched aircraft, gave the British a slight advantage in the battle because they could see and monitor the German aircrafts better than Germany could monitor and see the British aircrafts. In the top right, we have one of the Supermarine Spitfires that Britain created. Germany's invasion of Russia in June of 1941 was a turning point for the battle against the British. Germany had more fuel to fight because of the close proximity, whereas British fighters had to go back and refuel often. This gave Germany a significant advantage. In August of 1941, the Germans introduced the Focke-Wulf FW-190. This plane could go well over 400 miles per hour and had an air-cooled engine unlike the liquid-cooled engine of the Me-109. The switch in the cooling system made the plane more robust and it could take greater damage while still being able to fly. This is because if it got hit in the engine compartment, there was no liquid-cooled system that could possibly break. Instead, it would constantly be air-cooled no matter what the enemy could throw at it. In the top right, you can see the Focke-Wulf FW-190. In 1942, the Germans created the Me-109 Gustav, or the Me-109G. This was by far their most produced and used plane throughout World War II. The modifications given to the original Me-109 allowed the aircraft to perform very well at high altitudes, giving them a significant advantage. America started bombing and assisting the war at the end of 1942. Americans' main fighter plane was the P-47 Thunderbolt, and like the German Me-109 and the British Spitfires, these planes underwent many changes and upgrades throughout the war. The P-47, with 8 machine guns built in, gave it significant firepower, versus the 6 machine guns on the Me-109 and the 4 machine guns on the Spitfires. At the top right, you can see the P-47 Thunderbolt. The P-47 matched the Me-109 in speed, however it lacked in distance when accompanying the B-29 bombers into deep Germany. They solved this problem by introducing the P-51 Mustang that had extra fuel tanks for longer range missions. Although they had extra fuel tanks and could go further, they still would have to turn around before getting to the bombing point because of the flak that would come up in the air. These planes were much more susceptible to flak than the B-29 Superfortresses. Around this time, the Royal Air Force introduced the Hawker Tempest, which, like the later versions of the Thunderbolt, could fly at well over 450 miles per hour. The Germans dominated The German dominated on the Eastern Front because Russia was far behind in development until mid-1943 when they introduced the MiG-3, even causing America and Germany to come and help on the Eastern Front when Germany tried to invade Russia. After jet propulsion. In 1939, the jet propulsion engine was originally created by Hans van Ohan. However, simultaneously in Britain, Frank Whittle invented a jet propulsion engine of his own. Frank then shared the information with the United States, and General Electric started manufacturing jet engines in America. The Heinkel HE-178 was the first ever produced jet engine aircraft. Although this aircraft flew a few times in 1939, the majority of jet propulsion aircraft that flew during World War II didn't fly consistently until 1944. At the top right here, you can see the Heinkel 178. The Germans and British both evolved on this technology, and they both had operational jet aircraft during World War II. The Germans had the Me-262, and the British had the Gloucester Meteor. Although neither of these planes flew in significant enough numbers to impact the war, the technology has shaped aviation into the huge industry that it is today. Although these were the only two planes to fly during the war, many countries had prototype jet propulsion aircraft on the ground for a long period during the war. In the top right, you can see the German Me-262. After the Americans got a hold of the technology, General Electric produced an engine for the Bell XP-59, which was the first American jet propulsion plane. The British continued development on their jet propulsion engines alongside the company Rolls-Royce in 1944 to create the Nimes engine, which they then sold to the Soviets. The Soviet version of that engine went on to power the MiG-15 fighter that fought our United States fighters during the Korean War. The surrender of Germany in 1945 led to many discoveries in the world of jet propulsion. With all the additional info they gathered from Germany, the British, American, and German engineers all came together and worked on a better jet propulsion engine than they'd ever seen before. And in the top right, you can see the Bell XP-59. Upon the discoveries made after the German surrender, General Electric, along with Pratt & Whitney, started engineering better jet propulsion engines. The issue with the early jet engines from World War II is that they gulped fuel at an astronomical rate, which needed to be solved before they could be especially useful to us. Pratt & Whitney fixed this issue by 1948 by combining two engines into one. This new engine that they created had two compressors that were independently run on their own engine. This led to the J-57 jet propulsion engine, which was put into commercial airliners such as the Boeing 707 and the Douglas DC-8. These original jet engines were the foundation for the jet engines that we see today. Many of these discoveries from World War II, if they would have never happened, we would have never advanced in aviation as much as we are today. Overall, jet propulsion wasn't used much in the war, but the technology discovered is still used in commercial aircraft today. In the top right, you can see the Boeing 707. This is my sources page. I use an article from Stanford about jet propulsion, an article from NASA about the Jet Propulsion Laboratory, a YouTube video on the aviation advancements made during World War II, and the last four websites you can see are just different aircraft that flew for different countries during World War II. This presentation was a lot of fun for me to do, and honestly, it really taught me a lot about the way that jet propulsion was created and why we had to create it. During World War II, jet propulsion could not go faster than the propeller-driven airplanes they'd already created, and they used more fuel. However, with time research, jet propulsion aircraft are now a significant market of the aviation industry today, and they can go much, much, much faster than propeller-driven aircraft. That's my presentation.